Hi, my name is Marijn. And like the lady who just spent 20 minutes talking amazing about AI and modern slavery, I am a social scientist. My dad, like many of yours probably asked, what the heck is your job going to be? Like, are you going to talk about people's feelings, sociology, criminology, statistics? So what I studied in Utrecht was to predict electoral outcomes, to model pandemics like Ebola over here, this is my work for Tower 555, and to predict how many people get stabbed in which neighborhood of Rotterdam, my hometown. Rotterdam here, anyone? Woo, good for you. A lot of stabbing, believe me, 80% of all cocaine in Europe passes through that harbor. A lot of cocaine. So I studied all of that, and then I applied to Capgemini, and they said, wow, that's cool, that's data science. And I said, because I needed a job. This is how 6 years ago I became a data scientist. Back then it was all big data. Anyone remember the good old days of big data? Yes, good for you. So what was considered big data 10 years ago? Too large to host on a single computer can now easily fit on my server in my closet. So big data is dead, long live big data. And nowadays they start calling all of my stuff, all of our stuff, AI. So for the next 18 minutes or so, I would like to talk to you a little bit about the data science projects we do and why the heck they call it all AI nowadays. Yeah, paint on face is involved. So I just made the joke here already about how the modern AI expert used to be a data scientist, used to be a statistician before that, and before that was just a nerd. Hands up, who here is a nerd? Or self-identifies as a nerd? Good for you. The rest get out. Anyway, as Sun Tzu wrote in the 5th century BC, modern AI is a hoax. True AI doesn't exist. We can talk for 15 more minutes about that. Instead, I'm just gonna show you some examples. Like roughly 3 hours before, I talked about how to predict burnouts using standard HR data. Last year, I talked about fraud recognition, about forecasting refugees. See the dip on the right over there? That was my refugee model for flows in and out of the Netherlands. It worked great until COVID started. That's when the red real line drops while my prediction goes up. And ever since, the prediction models have been shit. Last year we talked about classifying fossilized plankton to measure climate change through the centuries, to identify whales by the shape of their tails, and how to run automatic summaries of football matches, because damn, football is boring. Anyone disagrees? Hand up. Good for you. Get out. Anyway, this year we need to keep it simple. Let's talk about simple problems, easy to solve. Let's talk about gender pay gaps. Okay, hands up. Who here thinks gender pay gaps are a thing of the past? Who thinks they very still much exist? Ouch. I'm sorry, but you're right. They still exist. And it was roughly a year ago, I was talking to a large company, I can't mention the name, it's asking, well, we don't have gender pay gaps, and we have yearly reports saying it's only 1.something%. But ask why and how, where did it come from? Because it's easy to run a regression algorithm and take the b-value and fit that as your gender pay gap. Pay gaps are okay, let's be honest, pay gaps are okay. There is a difference in pay between the CEO and the young professional, that's okay, right? But it's only after you grab all the data, standard data in your HR systems, looking at the rank of people, their years in service, their education, and all kinds of other factors, that you can distinguish the professional factors from the non-professional factors that are not A-OK. And we use those models. For years we have already used these models. Google Scholar it. It's standard practice for organizations to report their gender pay gap at an organizational level. And that can be 2.something%. That's fine, because that's below the threshold of 5. What many organizations don't do, or don't want to do, because then they have to open up Pandora's box, is look at the differences between divisions. Because they may report the organizational pay gap, but they don't drill down and look at it per division, per unit. And that's usually where the actual pay gaps reside. Because gender pay gaps mainly result from legacy. We social scientists know, because new hires all get the same pay, but people from 20 years ago don't, so secretaries and such. And suddenly you see that only the secretary division has a gender pay gap. So if you just fire all of those, you no longer have a gender pay gap. Management didn't find that funny. I had no sense of humor. Either way, then we sell it as AI. We're using statistics, we're using machine learning to solve problems, and I'm proud to say this was implemented 2 weeks before the pay raises, so then the secretary's got a pay raise, yay. And all the while, the privacy officer was looking at me like this. Yes, I want the gender data of everyone. I want the ethnicity data of everyone. I want to know if they're gay or not. But if I don't have that, I can check if my model is sexist or racist or whatever, which is a huge problem in modern AI, where we already lock down all the data inputs we need to check if our model is safe. Because that is our true job as a data scientist, not to build a model, go all the way for deep learning, but to pick the right model for the job. Because there's always a constant trade-off between accuracy on one end and explainability on the other hand. And if you can't explain your model, then nobody's going to believe it, and they ain't going to use it. Plus, I'm a social scientist. I was raised on regression. Sue me. Anyway, completely different example, because we see a lot of deep learning, we see a lot of GANs, image generation nowadays. But how do you mess with a facial recognition algorithm? How do you make sure that it doesn't recognize you, doesn't match you on those fancy cameras in Rotterdam we need, because damn, it's a lot of coke. We ran an experiment for that. We called it Beat the Algorithm. Because modern facial recognition algorithms focus very much on the eyebrows and the shape of the nose and the eyes, because your mouth is usually covered these days, or used to be. So if you paint your face like a tiger, the horizontal stripes match eyebrows, and the model can't catch you anymore. If you use a lot of color patches like a panda, it also doesn't recognize you anymore. And if you hide as David Bowie, like I did, actually then it still matches you. So this is something we regularly run at events now and at parties. Big recommendation for parties. Grab the biggest GPU you can find, run image recognition and facial matching algorithms, and have people dress up, get their faces painted, and wear silly hats and see if the algorithm can find them again, because they take a picture with and without the disguise. And if the machine can't recognize you anymore, then you won. The one dressed up like a panda won Lego, because of course, it takes a real hero to dress up like a damn panda on a professional event. My combination of Mick Jagger, David Bowie, Mike Tyson didn't work though, because the eyebrows were still visible. And then we got the question, so who does this model work for? And I said it works well for white males, because after 1-2 days of training at events, we mainly had data on white males. And then the organization was like, isn't that a bad thing? We now have racist, sexist AI. And I'm like, no, that's a good thing. That's what I wanted to show you. If you have shit data, you get a shit model. That's not a unique situation. Because there are no unbiased algorithms. I can just tell you that. I'm sorry, explainable, trustworthy AI does not exist. But there are no unbiased humans either. And we need one to control and double check on the other. Because sure, any model, any AI can be biased. But I don't trust my models. But I trust humans even less, I'm sorry. So we need both, and data is a tool to recognize that bias and to fix it. How are you going to prove there's gender pay gap bias without data on it? That said, let's switch to a completely different topic, the World Food Program, which we've been working with over the last year. Now, who here knows the difference between a nutritious diet and an energy-sufficient diet? That's okay, neither did I before this. So, energy-sufficient means you have enough food not to starve to death. Nutrient sufficient means you actually have enough nutrients to develop properly as a child, as a human being. Slightly below 40% of the world currently does not have access to a fully nutritious diet, which in the short term is terrible, and in the long term is disastrous, because then you have generations growing up with physical or mental disabilities, which in turn screws over the economy, yada yada. So, the World Food Program advises governments of developing nations all over the world, running tons of simulations, 50 to 100 per region, per country, on how to fix the nutrient gap. What policy can they best enact to feed as many people as cheaply as possible? Should they import more maize? Should they subsidize rice? What to do if suddenly, I don't know, the world grain prices spike? What to do? What to replace that with? Strangely awkward, relevant example right now. And this is what they run it in. And this is also the core problem that we aim to solve, because they run it in Excel and Delphi. So we built Python-based models running in AWS, our sponsor, and running on Tableau, so they can now run these models, these tons of simulations and optimizations on what the best move is within minutes, not in a week. And I'll tell you, last month we had the first MVP ready of this, and the dashboards weren't ready yet. So the algorithm is now super fast, but the output is still Excel. And I was very ashamed of that. And Claudia approached me and said, Marijn, it used to take us a week, now it takes us minutes. I don't give a damn that the output is still in Excel, which was a very good moment for me to realize that I'm obsessing way too much over how pretty it looks, just like all of us here, and not enough on what it actually does. Because we can use data to help so many people, and that's what I love to do, and that's what I love to talk about. I don't care if you call it statistics or not. Here we're helping farmers in India and Kenya, the Maharashtra and West Bengal areas of India to be specific, where you have a lot of smallholder farmers. 50% of India is smallholder farmer, for example. And we built this data platform for them to automatically get recommendations on, okay, if I plant maize, what will I get end of season? If I plant rice, when do I need to water it? Hint, you don't, because you plant rice in water. And how much fertilizer should I throw onto my field? Which is a simple equation, but people just buy all the fertilizer they can and throw it onto the field. But I'm sure you can imagine more fertilizer doesn't automatically mean more yield. There is an optimum. We calculate the optimum for them. And I could show you the Hindi version of that, but you couldn't tell what it says, me either. And we can use satellite imagery for that to check the boundaries of their plot sizes, because most of the male farmers brag about their plot sizes. This is the thing. And we can check forest fires in the neighborhood, we can check soil quality, but the most effective thing is actually the linear optimization for fertilizer, because that is their biggest need. And in that regard, our goal shouldn't be to solve everything with AI. Our goal should be to combine data and scientific methods to solve real problems for real people and help them make better decisions. And that, to me, is the definition of a data scientist. God knows what they'll call it in 5 years. Because I started out in this field over 12, 14 years ago, something like that. WikiLeaks, anyone remember WikiLeaks? Well, I remember. Suddenly we had a boatload of data to prove to the American government, who said, Afghanistan war is happening over here. And we used data classification, text analytics in 2009 to show, no, war is also happening over here. To me, that was the point in time when I discovered the power of data and the power of truth, and speaking truth to power. And now 14 years later, the world is still fucked up. Okay, we still watch journalists get shot, but now we do it in HD. And we have a lot more data and we have a lot more models to deal with it. Now we use Tinder to track Russian soldiers. Some of us do. We still have anonymous doing DDoS attacks, but now we also have cartoon dogs raising more money than some states can. And we have Iran, whose revolution is almost completely dependent on internet connection. Please do not forget that dependency. Now a question to you all. When did you learn to type? When you were like 12, when you were like 16, 18, just remember that. And then realize that the generation before you learned to type 5 years later. And the generation before that probably didn't learn to type at all. They just said, I don't need to learn how to type, that's what the secretary does. Just like in the past, people said, no, I don't need to learn to read. That's in the same way people nowadays say, no, I don't need to learn how to use a computer, right? Learning to type and learning to read all happens sooner and sooner in our age, in our society, as technology advances. We've gone from written books to printing presses to computers to now tablets everywhere. Oh, the kid is so smart because he can run a tablet. The tablet is tested on monkeys, but that doesn't matter. We are adopting technology earlier and earlier in our lives, and it is my honest belief that math, shudder, and statistics and running models will become the reading and writing and typing of the future. Most of you learned how a regression algorithm works during your study, right? You had classes in statistics. As access to statistical or machine learning models becomes easier in our future because they're all stuffed into tools, and you don't need to learn how to code because the code doesn't run and you get syntax error, yada yada. As that becomes easier, more and more of society will adopt AI technology, and that, ladies and gentlemen, will be the true revolution. But the time difference between invention of technology and its mass adoption is usually roughly 20, 30 years. Sun Tzu said it best. New technology is never the problem. Legacy is. And Sun Tzu, in the 5th century BC, he knew this. Because all this data, all this AI, all of it ain't shit if we don't use and apply and share it to help improve people's lives, to help save lives, because the average Joe, the average Joette, who's just trying to survive, in 5 years' time, they call it quantum maybe. But regardless of the buzzwords, I know that I'll still be doing good with data. So see you later, and Slava Ukraini. I will take your questions now. Anyone dares, please don't tell me there was actually a coherent story.
Thanks for your talk. I'm actually interested in the first part of your presentation, especially on the gender gap and ethnicity, and you talk about the importance of data. How do you deal with that in a continent that is very reluctant to use data based on ethnicity, for example?
You mean most countries?
I wouldn't say so. I would say I think there is a lot of, for instance, Europe has a lot of reluctancy because of the past in order to collect data on race, for example. But then you use a lot of proxies in order not to say the word race, and then governments can actually collect the data for security threats, but then that data is not used for things like gender gap or stuff like ethnicity gaps.
I'm going to straight up admit this is a large risk, but just because of a risk existing doesn't mean you automatically shouldn't do it. Only if the risk is greater than all the other risks combined. Because what we are creating right now, by locking away this type of data, access to this type of data, I've seen this, I've been at 2 banks, 5 governments. We have one very popular government here in the Netherlands who had a huge affair with profiling. Every government does that accidentally. This is just the one that hit the news. The main problem here is that you have privacy, you have transparency, you can't have both. So whatever privacy we maintain for the individual comes at the cost of the transparency of our decision-making algorithms at scale. And a lot of organizations, with all due respect, focus so much on preventing risks, on minimizing it, and on saying, no, we can't do this because of privacy, because they don't want to admit that if they actually build the transparent algorithms, you're going to see a whole lot of shit. Pardon my French. So it's a trade-off. That's basically it. Either I just insulted people or there really are no more questions. Over there.
Hi, I think I really appreciate your presentation. I appreciate the fact that you came from a social science background and are now applying machine learning techniques to solving social problems. And you mentioned that in the future we're going to be a society that's much more literate in ML solutions from a younger age. But what do we do about the big gaps that exist right now within our workforce, particularly among particularly among social scientists who feel a reluctance to become involved in the world of machine learning? Because I think we need more people who have that social science sensibility involved in building ML technologies.
Basically, we need more people to help bridge that gap, because I was scared shitless back when I was applying, when I was done studying, and Capgemini luckily took me in, because with all due respect, I screwed up my intake until they asked me, so what was your thesis about? 15 minutes later, I was done predicting how social survey data can be used to predict how many people get stabbed. And then it said, wow, that's cool. That's how I got the ball rolling, almost on accident. And I want to share with you, that's why I started doing all these talks, to share with you, especially the students, hand up students. Okay, that's quite a few. That there's no need to be scared, that the market is very good, and your knowledge is very much wanted, just not in the way that you think it is. Because your professors, in a room with the professor, everyone was always smarter than you. Suddenly, you enter organizations and business, and suddenly you're the expert. That is scary. And they're all using different words for the same stuff. They don't call it statistics. They don't call it fitting. They don't call it methods. They just call everything blockchain and AI. But that is the very core tragedy of humanity, that sometimes we mean the same things but use different words, and sometimes we mean different things and we use the same words. So let's bridge that gap. Thank you.
Mahan Dankjewel. Thank you for this. I have two questions. First one is easy. Do you want to be friends?
Yes.
Okay, great. Thanks. Second one is I really love a lot of the stuff you presented, and I also would like to apply some of my skills for doing useful stuff. But yeah, I get paid to make rich people richer, like many of us do in AI, blockchain, data science, whatever. How do we get paid to do well? Because I also have kids, you know.
This is a generic consultant problem. I'm going to give you a cheat code here, basically. Skills you acquire in one domain can then be applied in another. I spent years working for financial institutions, and with all due respect, mortgages ain't my thing. But if I then apply those to help model refugee flows based on hamburger prices, then suddenly I'm doing something good. And you can go straight to governments when you're done studying, sure, go for it, kids. But you ain't gonna work with cutting edge technology over there, if you catch my drift. Because they ain't gonna be there in 10, 20 years, which is why our companies will have business for 10, 20 years. But if you learn it in one place and you apply it in another, learn it from a startup, a scale-up, whatnot, that is actually when you can make the biggest difference. And 3 hours ago we talked about the Great Resignation, and I'm going to repeat one point of that, which is that people want to try different things. Especially for the students, you're young, you're stupid, you don't know what you want to do, and you're not going to figure that out by doing one thing, because the odds of that being the one thing you want in life is statistically insignificant. The odds are much higher that, you liked it, but now you want to try something different. So, try many different things. This is also why the Great Resignation is happening, because people won't let you try different things within the company, so you switch to another company. Or you come join a consultancy company like mine, or like many of our competitors in here, plenty of people for you to talk to, so you can get to try 50 different things. And that's how you develop yourself, how you add more value. And I wouldn't be able to help NGOs nowadays, like I can nowadays, I didn't spend working through murky data at banks and Unilever, etc. So do enjoy. And I think I'm running out of time rapidly now.
Thank you very much.
Do like and subscribe, and until next time, thank you so much, love y'all.